This test is red. Playwright cannot find a button named Place Demonstration Order. An autonomous agent could increase the timeout, force a click, skip the test, or inspect the current interface. The evidence shows that the same approved control is now named Complete Secure Order. A one-line locator change can preserve the original business behavior. Now consider a second failure. The requirement says a 20% discount must reduce £24.99 to £19.99. The application displays £24.99 because it has added an unauthorized £5 fee. An agent could make the test green by changing the expected total. That would not heal a test. It would hide a product defect. That distinction is the foundation of this course. We will build a supervised autonomous QA workflow with Playwright Test 1.61.1 and its 3 official test agents, Planner, Generator, and Healer. The Planner will explore a controlled application and propose a markdown test plan. A person will review it before the generator creates tests. Those tests will produce browser, API, visual and continuous integration evidence. The healer will then receive both failures. It may propose the stale locator repair, but it must preserve the wrong price failure and raise a defect. You will also learn the exact boundary between Playwright Test Agents, their internal test MCP server, Standalone Playwright MCP, and Playwright CLI. We will initialize the workflow for Codex and Claude Code, inspect permissions, run it safely on localhost, and finish with a fair evidence scorecard. Watch the evidence trail throughout the course. Every plan, generated file, failing assertion, proposed diff, targeted rerun, and full suite result remains visible. That audit trail lets another engineer reconstruct not only what the agent changed, but why the team accepted or rejected it. The complete project is linked below. It uses synthetic credentials and a fake local order. By the end, you will have more than an AI test generator. You will have an auditable operating model in which the agent proposes, evidence verifies, and a human owns the quality policy. Autonomous QA does not mean handing product truth to a language model and walking away. It means allowing an agent to perform bounded work through visible tools with explicit inputs and review gates. The planner asks what should be tested and which observable outcomes will prove it. Its deliverable is a human-readable plan, not executable code. The generator asks how an approved scenario should become a maintainable Playwright test. It performs the real steps, observes useful locators, and writes code aligned with the plan. The healer asks why an existing test failed and whether a legitimate test-only repair exists. It runs and debugs tests, examines the current page, and proposes the smallest defensible patch. These roles remain separate for a reason. A plan should not become automation merely because it sounds plausible. Generated code should not be accepted merely because it compiles. A patch should not be merged merely because the rerun is green. We will judge 4 evidence lanes. UI evidence proves the represented browser journey. A PI evidence proves the server accepted and retained the expected order. Visual evidence proves one stable component matches a reviewed reference in a controlled environment. CI evidence proves the committed suite runs from a clean defined runner. Each lane has limits. One Chromium journey does not prove complete browser compatibility. One order contract does not prove every invalid payload. A receipt screenshot does not prove the checkout works. A green pipeline does not prove the product has no defects. This separation also creates accountability. Product owners approve values and outcomes. Quality engineers design the evidence contract. Developers review implementation effects. The agent supplies speed and structured investigation. No single actor silently changes the definition of correct behavior after seeing a failure. Our definition is therefore precise. An autonomous QA workflow is a bounded loop that creates auditable evidence. Its objective is trustworthy information about quality, even when the correct result is read. Human reviewers continue to own requirements, permissions, assertions, baselines, and accepted repairs. Four Playwright terms are often mixed together, so let us separate them before installation. Playwright Test is the runner and assertion framework from the @playwright/test package. This repository pins version 1.61.1, so the course, generated definitions and results remain reproducible. Playwright Test Agents are the planner, generator and healer definitions supplied with Playwright Test. We create them with npx Playwright init agents. Each definition combines instructions, permissions, and a role-specific tool connection for an agentic coding environment. Under those definitions is Playwright's internal test runner MCP server. The generated configuration starts it with npx Playwright run test MCP server. The planner receives setup, exploration, and plan saving tools. The generator receives setup, observation, logging, and test writing tools. The healer receives test listing, test running, and debugging tools. This server understands the Playwright test project, fixtures, seed, and runner state. It is not the standalone @Playwright/MCP package. Standalone Playwright MCP is a general browser automation server that exposes page interaction through structured accessibility snapshots. It is useful for exploratory automation, persistent browser work, and specialized loops outside a test suite. Installing standalone MCP does not create the three test agents. Playwright CLI is another agent-friendly interface. It exposes browser work through concise terminal commands and installable skills. CLI can be efficient for coding agents balancing repository context, tests, and browser actions. MCP remains useful when direct tools, rich introspection, and continuing browser state suit the workflow. When a setup is confusing, ask what state the tool understands. Standalone MCP understands a browser session. CLI understands its command session and saved artifacts. The internal test server also understands runner configuration, projects, fixtures, and paused tests. That difference explains which interface belongs in each loop. Do not run the hidden internal server manually and assume you have recreated the agent system. The generated definition supplies the job instructions, permissions, and correct tool allow list. For this course, the architecture is requirement, seed, planner, human gate, generator, code review, evidence suite, healer, and another human gate. Models may change. That control sequence should remain stable. You need Node.js 20 or newer, NPM 10 or newer, Git, and Codex or Claude Code for the matching agent loop. A GitHub account is needed only for the CI chapter. Clone the repository linked below, move into it, and run npm CIE. The lock file keeps the dependency graph reproducible. Then run npx Playwright install Chromium. Start the application with npm start and open http 127.0.0.14173. The Commerce Lab contains a Playwright field guide priced at £24.99. The account is learner@example.com. The password is Playwright!2026 and the discount is MCP20. All values are synthetic. Orders exist only inside the local node process and no payment occurs. Isolation is essential because browser agents execute actions. The generated planner includes a capability named Browser Run Code Unsafe. Treat it as equivalent to running code in the agent environment. Never point an experimental prompt at production, a privileged administration page, or a personal browser profile. Restrict the origin to localhost. Use a disposable branch, worktree, or sandbox. Keep application and requirement files read-only whilst agents operate. Never place API keys, customer data, private URLs, or production cookies in prompts. Traces, screenshots, videos, and reports may retain DOM and network data, so review them before sharing. The lab exposes 3 deterministic modes: stable, locator break, and price regression. Tests select a mode through a protected local endpoint, then reset it afterwards. This removes timing and data ambiguity and makes each read result intentional, reproducible, and safe to demonstrate repeatedly. Finally, run npm test before asking an agent to do anything. A clean baseline proves the repository, browser, and local server work together. If installation is already read, diagnose that environment rather than asking a healer to guess. Open requirements.checkout.mda. Instead of saying test my website, it defines a measurable user outcome. Alex Lerner can sign in, buy 1 Playwright field guide with the demonstration discount, and receive a confirmed local order. The acceptance criteria are explicit. The catalogue price is £24.99. MCP 20 applies 20%. Standard delivery is free. The exact rounded total is £19.99. The buyer supplies a name, address, and UK postcode and acknowledges the fake order. Confirmation must contain an identifier beginning lab-2026. The API must retain the same identifier, total, postcode, and confirmed status. The stable receipt must match its approved visual reference. The requirement also classifies our 2 future failures. Renaming the order button to complete secure order is approved interface drift. Adding a £5 fee is not approved. Writing that distinction before healing prevents a model from treating observed behaviour as the new truth. Requirements should also state what is outside scope. This lab excludes real payments, production identities, destructive administration, and automatic merging. Explicit exclusions stop an ambitious planner from inventing dangerous coverage and tell reviewers which untested areas cannot be inferred from the resulting evidence. Next, inspect tests seed.spec ts. A seed is a narrow, reproducible starting point. It resets the lab, opens the home page, and verifies the title, the evidence and human gates heading, the stable baseline badge, and the target product. When an agent uses the Playwright Test Setup tool, the runner can execute the seed through the configured project, including relevant setup, dependencies, fixtures, and hooks. That is safer than asking a model to invent the starting procedure. Keep these artifacts separate. The requirement owns business truth. The seed owns starting state. The plan will describe coverage, and tests will implement approved cases. This chain lets a reviewer trace every assertion backwards to an expectation and every claim forwards to evidence. For Codex, run npx Playwright init agents, loop-start Codex prompts. For Claude Code, run npx Playwright init agents, loop-start Claude prompts. The prompts option includes example orchestration prompts as well as the 3 role definitions. In Codex, inspect .codex agents. The planner, generator, and healer are TOML files with examples under .codex prompts. The planner and generator use read-only sandbox modes. The healer uses workspace write because a repair may require editing a test. Each definition starts npx Playwright run test MCP server and enables only the tools required by that role. In Claude Code, inspect Claude agents, Claude prompts, and @MCP JSON. The packaging differs, but the roles connect to the same internal Playwright test server. Generated definitions are code and policy. Review the command, tool allow list, model choice, file permissions, and written instructions. One detail deserves special attention. The generated healer may use test.fixme when a failure persists and it believes the test is correct. Our course policy rejects that as a repair. A skipped failure is still unresolved. Run git diff immediately after initialization. Generated files should be understandable, scoped and committed like any other development configuration. If a definition unexpectedly grants broader write access, starts a different executable, or enables additional tools, resolve that discrepancy before the first prompt is submitted. We also reject test.skip, test.only, weaker assertions, forced clicks, fixed sleeps, broad catch blocks, unexplained timeout increases, and unreviewed snapshot updates. The agent may propose, a human decides. Regenerate and review these definitions whenever Playwright changes. They are versioned instructions tied to the current tool surface. At this point, we have not granted unlimited autonomy. We have created 3 bounded job descriptions. We can now give the planner a precise, safe assignment. Open prompts 01planner.mdd. It tells the planner to read the checkout requirement, seed and safety policy. It restricts exploration to the local application, forbids application and test edits, and requires a markdown plan beneath specs. The plan must map every acceptance criterion to UI, API or visual evidence, include exact outcomes, negative coverage and limitations, then stop for human review. Invoke the generated planner in Codex or Claude Code with this bounded task. Its setup tool creates the page through the Playwright Test project and runs the seed. It then explores headings, buttons, dialogues, labels and status regions through browser tools. A useful plan records state transitions, not a list of clicks. Signing in should expose signed in as Alex Learner. Applying MCP 20 should produce the status 20% discount applied. The basket must show exactly £19.99. Submission must create a confirmation and an identifier matching the LAB-2026 pattern. The reviewed plan also includes invalid sign-in. The seeded email with a wrong password must create an accessible alert stating that the email or password is incorrect. API coverage creates an order, expects HTTP 201, checks its status and identifier, retrieves it, and compares the response. Visual coverage captures only the stable confirmation dialog and masks the generated identifier. The planner should not turn every visible control into a test. Prioritize the critical journey, meaningful negative behavior, and evidence required by the acceptance criteria. Coverage is a risk decision, not a count of page elements, and a concise reviewed plan is more useful than an unbounded catalogue. Remember that the planner can execute browser-side code through its unsafe capability. Keep the environment isolated and the task narrow even when the agent itself is read-only. The output is specs checkoutagentplan.md. It is valuable because product, QA and engineering colleagues can review it before code exists. But it is still a proposal. The agentic loop must now pause at Gate 1. Gate 1 prevents a polished plan from becoming automated misinformation. Map the plan back to every acceptance criterion. Count verified outcomes, not scenarios. Does it prove sign-in, the original price, the 20% status, the rounded total, required address data, acknowledgement, confirmation, identifier format, API persistence, and the reviewed receipt? Inspect data and authority. Every identity, address, and token must be synthetic. Every URL must be local. No step may imply a real purchase, message, account mutation, or destructive action. Check independence. Each case should begin from reset state. The API test must not rely on an order from the browser test. The visual case should create its own receipt. Invalid sign-in must not inherit a valid session. Replace vague expectations with observable ones. Checkout works is not a test oracle. The confirmation contains the same LAB-2026 identifier as the persisted API order, total 19.99, postcode SW1A1AA, and confirmed status is measurable. Record limitations. One Chromium journey is not complete compatibility. One API case is not exhaustive contract coverage. A screenshot is not functional proof. These boundaries make the evidence honest. A compact traceability table helps. Requirement, planned case, observable assertion, evidence lane and reviewer decision. Missing cells reveal gaps quickly. Duplicate rows reveal expensive repetition. If an expected value cannot be sourced from the approved requirement, pause and obtain clarification, rather than allowing the agent to guess. Finally, decide whether the visual target is stable enough to baseline. We capture one dialog and mask only the dynamic identifier. Any future baseline change needs design review. Approve the markdown only when requirement and QA reviewers agree. Catching a wrong value here is much cheaper than reviewing a generated suite that encoded it. Once gate 1 is recorded, the generator may begin. Open prompts 02 generator.mde. The generator may use only the approved plan, seed, and safety policy. It may write maintainable files beneath tests, but it may not edit the application, requirement, or approved plan. We require semantic locators and web-first assertions. We prohibit forced actions, fixed sleeps, skipped tests, fix me, only, and weakened expectations. The generated order identifier must be masked only in the visual comparison. The checkout must be proven through visible browser state and persisted API state. A baseline cannot be updated without human review. For each plan case, the official workflow sets up the page, performs each step in real time, reads the generator log, and writes one focused test. Cases run sequentially, so each result remains associated with an observed scenario. Execution before generation matters. The model sees the actual roles, labels, statuses and flows instead of inventing selectors from prose. Even so, inspect every line. Get by role and get by label communicate user intent. A long CSS path tied to layout is brittle. To be visible, to have text, and to contain text, wait for conditions. A 2-second timeout merely hopes. The repository organizes output into tests, UI, tests, AP, and tests, visual, with deterministic actions under tests, helpers, lab.ts. Reuse removes noise, but important business assertions remain clear. Review helpers as carefully as spec files. A helper can quietly weaken every consumer by swallowing a failure, using a fixed delay, or hiding the expected value. Keep setup deterministic. Return useful evidence such as the confirmation locator and order identifier, and let each test state its own purpose. Gate 2 is a code review. Verify comments, permissions, locators, and assertions. Run each targeted file and then the complete suite from reset state. The generator accelerates implementation. It does not replace test design or engineering judgment. Open tests UI checkout.spec.ts. The main test receives both page and request. Page drives the browser. Request talks directly to the local API, allowing one case to compare the user visible result with server persistence. First, Reset Lab returns the application to its stable scenario and clears old orders. Complete Discounted Checkout clears browser storage, opens the app, and verifies the starting heading. It opens the sign-in dialog, fills the labeled email and password fields, and expects signed in as Alex Lerner. The helper finds the article containing Playwright Field Guide and clicks its Add to Cart button. In the shopping cart dialog, it enters MCP 20, applies it, expects the 20% status, and checks the exact visible total of £19.99. It continues to check out, fills Alex Lerner, postcode SW1A1AA, and the synthetic automation street address, then checks the demonstration order acknowledgement. After submission, the browser must expose a dialog named Your Browser Workflow Passed. The dialog must show the approved total, and its order identifier must match the Lab-2026 pattern. The test then retrieves that identifier through API orders with the demonstration token. The response must be successful and contain the same identifier, confirmed status, total 19.99 and postcode. Notice that the locators describe accessible intent rather than styling. Dialog names define scope, labels identify fields, and roles identify controls. This makes the test both more resilient and more valuable as an accessibility signal. If semantic selection is difficult, the product interface may deserve improvement too. This cross-layer assertion matters. A confirmation dialog could be cosmetic. A stored API record alone would not prove the browser journey. Together they show that the represented user action reached persisted state. The second UI test submits a wrong password and expects an accessible alert with the exact error. These tests prove named outcomes, not every browser, security property, or checkout permutation. Precise claims keep evidence trustworthy. The direct contract test lives in tests API order.spec.ts. It resets the lab, posts the synthetic credentials to API login, expects an OK response, and extracts the demonstration token. It then posts to API orders with that bearer token. The payload contains one field guide, standard delivery, the controlled UK address, and total 19.99. Creation must return HTTP 201, confirmed status, the exact total, and an identifier beginning LAB-2026, followed by digits. Next, the test retrieves the order using its new identifier. The response must be successful, and the complete returned JSON must equal the created object. Playwright's request fixture also uses the same base URL configuration as the browser project, so local setup remains consistent. In larger suites, API setup can prepare state faster than repetitive UI steps, provided the final browser assertion still proves the user-facing behavior that matters. This lane answers focused server questions. Did authentication issue a usable token? Did creation use the correct status? Did the server retain the full order? Does retrieval return that representation? The browser test alone cannot isolate those answers. The API lane cannot prove that the sign-in dialog is accessible, that the total is rendered clearly, or that checkout is usable. It supplements the UI lane rather than replacing it. In a production project, you might add schemas, permission boundaries, malformed payloads, idempotency and error contracts according to risk. Do not generate hundreds of tests merely because an agent can. Here the status, total, identifier and persistence link directly to the approved requirement. Traceability matters more than test count. Functional assertions do not reveal every visual regression. Tests, visual, receipt, spec.ts therefore completes the controlled checkout and compares the confirmation dialog with approved receipt .png using to have screenshot. We capture only the stable dialog, reducing unrelated page differences. We mask the generated order identifier because it changes on each run. We do not mask the total, status, or layout under review. The configuration disables animations and allows a maximum differing pixel ratio of 1%. That tolerance is a project decision, not a universal default. It should reveal meaningful drift without turning harmless rendering noise into constant failures. A baseline is not correct merely because Playwright created it. A person must inspect and approve the first image. Every update needs the same scrutiny. Never allow a healer to refresh snapshots automatically just to restore green. Mask only information that is genuinely dynamic and irrelevant to the design decision. Broad masks can hide a real regression. Likewise, raising the pixel tolerance until a test passes converts a useful comparison into theatre. Record why every mask and threshold exists. Rendering depends on browser version, fonts and operating system. Compare baselines in the same defined environment. If developers use macOS whilst CI uses Linux, maintain reviewed environment-specific references or use one pinned container. When comparison fails, inspect expected, actual and diff images. Decide whether design changed intentionally, the environment drifted, or a regression occurred. A baseline represents a human-approved expectation. Changing it is a product design decision, not routine test maintenance. Before healing anything, create a trustworthy baseline. Run npm run typecheck, then npm run test UI, npm run test API, and npm run test visual. Finish with npm test for the complete suite. The course uses one Chromium project and one worker for deterministic teaching. Local retries are 0. CI permits 2 retries, so additional evidence can be retained, but a flaky pass still deserves investigation. On failure, Playwright retains a trace, screenshot and video. The HTML report is written to Playwright report and opens through npm run report. Trace viewer shows the action timeline, DOM snapshots, locator resolution, console output and network activity. That is a better starting point than blindly increasing a weight. The configuration uses retain on failure for traces and failure only capture for screenshots and video. This balances diagnostic value with storage cost in the lab. Production teams should tune capture by risk, because always-on artifacts can be expensive and can collect more sensitive information than reviewers expect. Treat artifacts as sensitive. A production trace can retain form values, page content, and requests. Apply suitable access and retention controls before upload or sharing. Record the green baseline commit. Now stable UI, API, and visual checks pass against an approved requirement and reviewed source. Without that known point, we could not distinguish a demonstration change from an older failure. Say exactly what green means. The specified checks passed in this controlled environment at this time. It does not mean the product has no defects. With that baseline established, we can introduce an approved accessible name change and observe safe healing. Run npm run demo, locator broken. The demonstration resets the lab, activates the locator break scenario, and prepares the approved checkout. The product button is now named Complete Secure Order, whilst the test still searches for Place Demonstration Order, so Playwright fails. Read the requirement before invoking the healer. Product explicitly approved this accessible name change. Price, discount, address, confirmation and persistence behavior remain unchanged. A test-only locator repair is therefore possible. Open prompts r03healer.mdd. The healer may run and debug the target, inspect the current page, and propose the smallest patch. It may not edit the app, requirement, or business assertions. It may not use skip, fix me, only, force, fixed sleeps, swallowed errors, or larger timeouts. It has at most 2 repair attempts and must stop for diff approval before applying or committing. Invoke the generated healer. Through the internal test runner MCP server, it can list tests, execute the target, enter debug mode, examine the browser snapshot, and generate a locator. The evidence shows the intended control still exists at the same journey stage with the approved new name. The valid proposal changes one role locator from place demonstration order to complete secure order. Nothing else should move. Preserve the diagnostic sequence as evidence: original failure, current page snapshot, approved requirement change, proposed one-line diff, and clean rerun. That sequence distinguishes reasoned healing from trial and error. If the agent cannot justify its patch from those artifacts within 2 attempts, escalate to a human. At the human gate, ask 4 questions. Is the product change approved? Does the new locator preserve the same user intent? Is the diff minimal? Has any assertion or execution control weakened? Accept only when every answer is yes. Run npm run demo locator.fixed, then reset and execute the full suite. A targeted pass proves this patch works for the controlled failure. The clean suite checks wider impact. That is safe healing, evidence-led diagnosis, a minimal change, preserved business truth, and an approval trail. Now run npm run demo.businessbug. This scenario adds an unauthorized £5 fee. The field guide costs £24.99. MCP20 reduces it to £19.99, but the application adds £5 and displays £24.99. The test expects the approved value and fails. Although this resembles the locator mismatch technically, its meaning is different. No requirement approved the fee. The test has found a product defect. Reject any patch that changes expected 19.99 to 24.99. Reject test.fixme, test.skip, a partial assertion that ignores the total, an unreviewed screenshot update, a catch block, or an inflated timeout. None repairs the product. The correct agent output is a preserved red test and a defect report. Record the environment, command, requirement reference, expected total, observed total, and £5 difference. Reproduction is concise. Reset the lab, activate price regression, sign in, add the field guide, apply MCP20, and inspect the basket. Attach the relevant trace, screenshot and request evidence after checking it for sensitive content. State the impact. The represented customer would be charged an amount that violates the approved discount and free delivery policy. A useful defect report also states what was not changed. The test assertion remains 1999, no baseline was updated, and no scenario was skipped. That protects the signal whilst the product fix is developed, and gives the eventual repair a stable regression check. Assertions encode business truth. They are not ordinary lines for an optimizer to edit. Some failures are test drift, others are environment or data faults, others expose product defects. Healing begins with classification, not modification. An autonomous QA engineer earns trust by refusing a dishonest green result. In this exercise, red is the correct and valuable outcome. Open GitHub Workflows Playwright.iml. The workflow runs on pull requests and pushes to main with read-only repository permissions. An Ubuntu job checks out the source, installs Node 20, runs npm CLI, installs Chromium with its system dependencies, and executes npm test. The HTML report uploads even after a failure unless the job is cancelled, with 7-day retention. Change access and retention to match your organization. For visual tests, use a baseline produced for this CI browser and operating system, or run both local and CI comparisons inside one pinned container. A successful workflow proves that this commit passed the named suite on the defined runner. It does not prove the entire product is defect-free. A failed workflow is evidence to investigate, not permission for automatic assertion changes. Do not let retries conceal instability. Report whether a test passed first time or only after retry, and retain the failed attempt's trace. An autonomous reviewer can group symptoms and propose investigation, but the branch should not be described as healthy until the underlying flake is understood. The repository also includes docs, Codex vs Claude scorecard.mde. Compare agents from 2 clean branches or work trees at the same commit. Keep Playwright 1.6.1.1, requirement, seed, prompt, model version, permissions, time limit and data reset identical. Score observable engineering results. How many acceptance criteria appear in the plan? Did tests pass before healing? Did review find brittle selectors, fixed sleeps, forced actions or weak assertions? How many human corrections were required? Was the repair minimal? Did targeted and complete reruns pass? Were the plan, test diff, trace, report and CI log retained? Record measured time. Codex expresses generated agents through TOML and sandbox modes. Claude Code uses Markdown definitions and MCP configuration. Both drive the same Playwright Test Agent architecture. Do not score confident prose or declare a universal winner from one run. Models and permissions evolve. The meaningful comparison is which controlled execution produces cleaner, stronger, and more reviewable evidence. Let us assemble the complete workflow. Begin with an approved requirement containing exact outcomes, controlled data, scope, and at least one failure that must remain red. Write a seed that creates a deterministic starting point without hiding the behavior under test. Pin Playwright Test and initialize the matching loop with npx Playwright init agents, loop codex, prompts, or npx Playwright init agents, loop Claude, prompts. Review every generated instruction, tool allow list, and file system permission. Regenerate them after a Playwright upgrade. Run the planner only against an authorized environment. Require a markdown plan that maps requirements to evidence and records limitations. At Gate 1, review coverage, data, permissions, and business truth. Give only that approved plan to the generator. Demand semantic locators, web-first assertions, and deterministic setup. At Gate 2, inspect every diff, run targeted files, and then the complete reset state suite. Build independent evidence lanes, browser behavior, API contracts, a focused reviewed visual target, and a clean CI run. Protect reports and traces as carefully as logs. In a production rollout, begin with recommendations only. Measure acceptance rate, unsafe proposals, escaped defects, flaky reruns, and reviewer time. Expand write authority gradually, keep automatic merging disabled for high-risk changes, and ensure every agent action can be attributed, reversed, and reproduced from retained inputs. Give the healer one bounded failure at a time. Require diagnosis before editing. Limit attempts and reject skip. Fix me, only, concealed errors, weaker assertions, and unexplained timeouts. Approve a locator change only when the requirement and runtime evidence show that user intent remains the same. Preserve red when the product violates an approved value. For your capstone, create one approved interface change and one true business regression. Run Codex and Claude Code from equivalent branches and compare plans, patches, reruns, and artifacts with the included scorecard. If every automated decision traces backwards to a requirement and every quality claim traces forwards to inspectable evidence, you have built more than an AI test generator. You have built a supervised autonomous QA system. The repository, prompts, safety policy, and commands are linked below. Adapt them to a disposable staging application and remember the rule that should survive every model change. The agent proposes, evidence verifies, and the human owns the quality policy.